Hello everyone, welcome to our next lesson, variables. Variables is one of the very important lessons when you are learning programming languages. However, if you only read it at the very surface level of variables, is just a container to hold the values and start using them right away, then you will not have a deeper understanding. And especially if you are somebody who is going to work on embedded systems, you need to have a very good grip on variables. Some of the systems, like our space programs, our missiles, the rocket systems, in many of these mission critical systems, and even some of the info entertainment systems in, say, aircrafts, the fighter jets, many of these places, the default language they use is C, C++, and some embedded programming languages. In all of those, where they are constrained by memory, it is very important to know what is the type of the variable, how much memory does it take, when it get created, when it get destroyed, can it be modified. Knowing all these details would really help you to write better programmers and become a better software engineer. So let's first understand, like I keep telling every time, that before you learn any technical concept, you have to understand why it is being designed that way, or why does it exist. Like I have been telling you that whenever you want to learn any new concept, you need to understand why it exists. So in this case, the first question that you ask yourself, which is why. Why variables exist, and it is also called basically a first principle thinking. What if variables did not exist? What if variables did not exist is, let's say you have this processor, and your processor is the most expensive component of any computer. And in this most expensive component, it has only some registers. It has some registers which actually have a memory. So these have memory. Now, any computation that you want to do, be it arithmetic or logical, when you want to perform any of these computations, those values have to be copied to these registers. Let's say you want to add 10 with 20. These values have to be copied to the processor, to its memory, which is registers, and then you perform that mathematical operation or arithmetic operation or a logical operation, and then the final result again is given back to the program. Now, if we didn't had concept of variables, it would have caused a lot of challenges. The first challenge is, then all that values you have to store here in CPU. Your CPU, would have become really extremely large and expensive. So the variables allowed you to store that all in RAM, and they would have a unique address. They would have some unique address. And whenever you need those values to perform any operations, they would be copied to registers in the RAM, in the CPU, in the processor, perform those operations and return back. The modern CPUs that you have, like say Intel i7, Intel i9, or even the latest AMD processors, they all come with even additional memory with the processor, not just the registers. As the softwares are becoming more complex and more heavier, then back and forth between RAM and processor we were losing time. So now modern processors come with little bit additional memory. They call it cache, processor cache memory. So they also come with that, but it's very tiny, very small. The second thing is, when you're running your program, you need to take the user input. When you're running the program, you need to take the user input and then run your code. The best example is your UPI app. Let's say a person one want to transfer money to person 2 through UPI. What if in the UPI app they have not used variables? If they did not use variables where they can take that input, then it means they'll hard code the value. So they will say that, okay, anytime you transfer the money, you will only transfer 1,000 rupees. They'll hard code some number. So if they hard code the number, then you can only transfer 1,000 or in the multiples of 1000. If I have to transfer 10,000 from this person to this person, then that person has to trigger 10 transactions of 1000 each. And if anybody want to transfer less than 1000, they cannot do it. Because they use a variable here, there is a variable here, you can enter the value anything from 1 to 1 lakh, 1 rupees to 1 lakh. Because why is 1 lakh? Because our RBI has set the upper limit saying in a single day, maximum money that you can transfer to UPI is 1 lakh. And the minimum money that you can transfer to anybody is 1 rupee. So that variable, they have declared a variable in that app. And whenever you type the amount, it takes that value and it runs the program. So there is a real life analogy, which is like, say, you have a container, right? You have these containers in your kitchen, and let's say you are storing sugar here, you are storing tea powder here, and you are putting a label on that box saying, hey, this is sugar and this is tea powder, right? So literally, the variables are in your RAM. As you store those values in the RAM, when you store those values, they are stored at a particular address. Let's say this address is 2000. The addresses are generally in hexadecimal, so I'm just writing in decimal so that you understand it clearly. And the value stored here is 10, and the address here is 2000. Your variable name, let's say the variable name here is number 1. This variable number 1 actually remembers this address 2000, and in your code you will say that read the value at address 2000. When you are doing answer is equal to number 1 plus number 2, what is happening? Literally, this is number 1, and there is another variable called number 2 in RAM, and let's say this address is at 3000. Okay, then your final answer is another variable. This is your answer variable, and this is at, let's say, 5000. Okay, so literally you are saying your answer is one variable. You read the value at number 1 and number 2, you do the addition. So what happens is the processor goes to address number 1 and it fetches this value, which is 10. So the 10 value get copied to the processor to its register. Then it goes to the next variable, which is number 2, which is at address 3000, and fetches this value. It does a computation, it adds it, and whatever is the result or answer, it copies it in the RAM to the third address, which is answer here, 30. And similarly, in UPI app, when user enters 10 rupees or 20 rupee in the RAM, first that value get copied here, and from there they make a request to backend server saying transfer 20 rupees from person A to person B. That as you enter and press the button, that value need to be read, so it need to be captured and stored in the RAM first, and from RAM they take all the data and make a network request to the backend system. So variables are very much heart and at the center of programming. If you don't understand variables thoroughly and clearly, then I don't think you can be a great software engineer. So please pay attention, and let's now go in a chronological order of. So I think we understood why variables exist. The first thing, we could have hard-coded the values also, right? If we hard-code the values, what will happen? Even to hard-code the values also, you need some variables. Sometimes you can directly hard-code with using mathematical expression. You can directly say answer is equal to 10 plus 20. Okay. Now, what is the use of this software where it will only add 10 plus 20 every time you run it? Is there any practical use or human application for this? Can the society use any software like this where it will only add these two numbers? Say, if it can accept that numbers from users and add, then there is some value of it. Then there is some use of that software. But if the values are hard-coded like this, then what is the use? This is why variables exist. Now, as I told you multiple times that RAM is most expensive than the hard disk. RAM is like a real estate in Bangalore, right? So it is more expensive than the RAM real estate probably is more expensive than, MG Road or HSR layout in Bangalore. Since it is expensive, if you need 1 byte, if you need 1 byte of memory, and if you end up allocating 4 bytes, then this is a waste. So as an engineer, you need to know what is the range of values that I would need for this variable and choose appropriate data type. If you do a wastage, then what will happen? There is a very strong implication of this. As many of you know that Python is being used a lot in data analysis and machine learning and AI, and even in some backend systems, right? So if you do a wasteful, if you choose wrong data type, you needed only 1 byte of memory and you ended up using, let's say, 25 or 26 bytes. Okay. So you're using this much more. Because it's not that you intentionally did, you did not understand the details, and because of that you did this. Okay. Now what will happen when you deploy that on the server or a computer to run again and again? It will demand more memory, and even the servers have memory limitations, right? So this is one variable. Let's say you are declaring 10,000 times this variable in that program, so you will have that much memory requirement. Now what happens is you cannot run it on one server, so you will rent more servers on the cloud. Since you rent more servers on the cloud, your bill that you have to pay to the cloud providers will run into huge sum of money. I have a friend who is a technical director in one of the biggest retail chains in India, and they had these data pipelines written by some engineers where many of these factors were not paid attention to, and their data center or their cloud bill was running into multiple crores of rupees. And when they paid attention to all of this and optimized it, it was reduced to less than half a crore. So that is how important it is. It directly translates to money. So when you are learning variables, pay that extreme attention, because this directly translates to money. If you don't know this detail and you make mistakes here, then it may have a financial loss to your company. Okay, this is one part. The second part is, to run computers you need a lot of power, and to generate power, a lot of fuels are being burnt, and the lot of fuels, when you burn, that adds carbon dioxide. So if you write a program that takes a lot of power to run, it means you are adding more carbon dioxide to our environment. So it is not just financial loss, it is also environmental loss if you are assigning more memory than what is being required. Because your software, especially backend software, keeps running 24/7 in the cloud. Now with this context, I am sure you will pay more attention to details of variables. So let's go in some chronological order of in which way we need to learn this one. So I gave you this example that variables are like labeled containers. So that is the example I was giving. It is like a labeled container where you reserve that space here in the RAM, and in this value is getting stored. Now there are in some programming languages you can update this value. You can change this value, say from 20 to 200. In some languages it will create a brand new space and store that value. I will explain that little later in the same section here. Now what are the data types? So data types, since we deal with different type of data, every programming language has come up with different data types. So in the numeric side, where you store numbers, you have primarily int, float as a data type, and then there is another data type in Python called complex. So this is the integer values, these are floating point values. And the text, lot of software deals with text, and that is a string data type. Here they have given an example with the double quotes. Then there are other data structures. Probably these ones we will cover them in a separate chapter, because if you get into data structure now, it can be a little overwhelming and confusing. So for time being, let's skip this two and get into the third one, which is Boolean. So Boolean is a data structure which can store only two values, true or false. When you write software, there are many situations where you just need true or false, and Boolean takes generally 1 byte of memory. And instead of using Boolean, if you use integer, you may end up taking lot more memory than that is required. So please pay attention. Boolean is a data type where you can store true and false, and it takes only 1 byte. Then you also have binary, where you can store byte stream. Okay, so we'll explore all these data types, and we will write code and try to see how this is. Now, what is type checking? As I explained here, data type means this is the type. Is it int? It is float. This is called type. Please remember this word, because when you explain the technical concepts, you need to use these technical jargons. Otherwise, your explanation does not make sense. You will start saying that will happen, this will happen, that thingy, this thingy kind of a language. So when you say that thingy, this thingy, then we know that you have not remembered the technical terms. Please remember the term type. The type determines, which is also called data type. Data types tell what is the type of data that you can store. Okay. Now, the extended concept of this is called type checking. And what is type checking? If you have a data, you can do reverse. You can write a small piece of code and check what type of that data it is, and that is called type checking. And there is a concept of type mismatch. Type mismatch means you cannot take a string value and add it to an integer, or take an integer and add it with a string. So that is called type mismatch. And there is also a concept called type casting. Type casting is changing it from one type to the other type. So data type, type checking, and type casting. You remember all these three terms. Type checking means given a value, you find what is the type. Type casting is you convert from one to another. Let's say you asked a user to enter their age, okay, and they entered the age as 18. Now when they enter that age as 18, from the keyboard it is read as 18 as a string. It is read as 18 as a string. Okay, and you want to do a logical operations to know whether the person is eligible for getting a driving license or not. So you will say what? You will say if that person's age is greater than 18. But this is a string value. This is not a decimal value. So from string you have to convert it to decimal value. And that conversion is called typecasting. So you will change the type from one type to other. That is called typecasting. Now let's look at the other concepts. What is strongly type? Strongly typed means if you have assigned a type of integer, then you have to use it as an integer. Okay, you cannot assign a type as integer and then start using it as a string or vice versa. So that is what is called strongly typed. And any type mismatch you do, it will cause an error. And here is a very small demonstration. So if your type is, let's say, 10, which is string, one variable is of type string and the other variable is of type actual integer. And if you try to print this x plus y, you will get a type error, and we will try to do this and see it on our computer right away. So let's stop it here, and whatever we learned, right, so we'll try to run this on our code and debug it and see it. So let's declare our first variable and create a file here called variables.py. Okay, now as you saw in that example, sugar is equal to 2 and water is equal to 1. Okay, so you are saying sugar is equal to 2 and water is equal to 1. Okay, so what happened, and then what is the third line that we are saying here is we are printing something. What are we printing? We are printing making a tea with sugar and water, right? So let's copy this line also. Okay, so the variable name here is sugar and the variable name here is water, and the value here you are hard coding is 2 and 1. When I refer that here, what will happen? And in the previous lesson you learned how to debug the code, right? So what we will do is debug and see what happens. So I set a breakpoint here. You can see that red dot. I just went here and clicked my mouse, so you see a red dot, and then go here and say Python debugger and debug the file. So this is the watch. So what you do here in the watch, you press this plus icon and add sugar. So what is sugar saying? It is saying sugar is not defined. Why? Because your Python interpreter has not yet run this line. It is waiting here right now. So only when I say next, it will run that line. Okay. And when it run that line, what will happen? What happened? In RAM, in the RAM, this variable got declared here as sugar and that value 10 got stored. So this sugar here, the variable sugar here, it got value 2. And then the type of that variable was also set. If I hover on the type here, you can see a pop-up which says is it of type integer. Okay. Similarly, now when I run the next line, one more variable got declared. Okay. You can see here under the local variables. I'll explain local and global variables in a short while. Just hold on. Don't get confused. I'll come back to this local and global. For now, we will use the watch. So you will say water. Water is 1. Okay. And here when we are calling a print function, I have not yet explained you print function. I will explain functions in my third or fourth lesson where we will go at the depth of it. For now, for you to use print function, you just remember that this function is like a servant. Your program is giving a work to this servant saying that do some work for me. And what is that work? The work is that you print this string on the console. What is the console or the terminal is this? Either here or on the command line. So you are telling it to do that. Okay. And what happens here is this function is not, this code for this function is not written by you. It is written by the person who developed Python. A lot of these functions are installed on your machine when you install the interpreter. So these are generally called as standard library functions. So here this function code is already written in which they have written how to print this on the terminal. That code is there. So you don't have to write that code by yourself. Okay. So you are invoking that function and asking it to do the work, and how functions work, what they do and all, I'll explain it in the subsequent lessons. So here you ran the function. Now you can see that making tea with 2 teaspoons of sugar and 1 cup of water is printed. So here that values were read and the answer was printed. So it could be a very simple other thing also, right? It could be like what example we gave, say num10 1 is equal to 10, and you can say num2 is equal to 20, and then sum is equal to num1, or you can say sum is an answer is equal to num1 and then plus num2. It could be as simple as that, and then finally you say print answer. Okay. So again, I'll just set one breakpoint here and I'll just debug this code. Now you can add those values here. Let's say you added num1, which is 10, num2, which is 20, and then you say answer. Here it is saying answer is not yet defined, but once you run the line, it got defined. It took these values, gave it to CPU added both, final result came back, and in the RAM a main reservation was done, and then a space was allocated here and the value was copied. So that 30, you can see that it's there, and now when you print it, we are able to see the output. Now let's do a type checking. So you learned the concept of type checking, right? So what is the type checking? You can check the type of the variable. So, and I will show the examples for each one of these, okay? How to declare those variables. So let's do this type checking. Print type and copy this one. So you have variable x. I set one breakpoint here. Again, run it. So what is x now? X is of variable type integer, right? Because you are copying an integer value. So print is invoking another function called type. This type, what it will do, this will take this special variable and return back what is the type. So when I print this, we'll see that the output is that it is of type int. Now you all may be confused why it is saying class. In high level languages like Python, Java, C Sharp, the integer variable is not a primitive data type. It is a object, which means it is a class. It's created by a class of type int. So what is primitive and non-primitive is something I'll explain. In older languages like C and all, the integer variable used to be a primitive data type. So there is no class or object. Int means it is an integer variable with 4 bytes of memory. But in high level languages, it actually is not just a 4-byte variable. It itself is an object, which means it will definitely take more memory, but it will come with its own advantages, and those advantages we'll see it soon. And is instance, okay, so it's checking is instance x is an integer. So what is it saying? Is x object is an integer. So then the answer that it is returning is true. So you can see that it's returning true. So why type is needed? When you are confused, you don't know what type it is, you can use this function to see what type it is. Let's say I will declare another variable, and this time let's make it y and store the value 1.2. Okay, and let's see what does this print. Then similarly I'll do one more, which is, let's say, x, y and z, and I'll store the value Mahesh. Okay, let's remove this and let's print that value also. So what will be the type of this y now? Will it be int or not? Let's see. So it's of type float, floating point, right? And what will be the type of this value, Mahesh? It is of type string. Okay. Now every variable that you are declaring here is of certain type. Okay. Now let's say another one, result is equal to true. Okay. Then we'll also print type result. Okay. So I think int, float, if you learn these data types initially to begin with, is good enough. So I'll just run this and you will see that the class here is bool. Now the most important thing, how many bytes does each one of this take? So how to find that? For that you have a function which is called size of. So you search for size of. So for that you have to import a package. Right now you don't worry about this. I have a separate lesson on importing packages. I'll cover that. I don't want to mix it up with variables. Just for time being, you know that you have to write this line at the top. Okay. We'll come back to this in our subsequent lessons. And then what is the function name? The function name is system.getSizeOf. So what I'll do, I'll just copy this whole line and we'll print that line in our code. For each of the variable we'll do this. Okay, so our first variable is this, our second variable is this, our third variable is this, our fourth variable is this. Now for each of these variable I have to change the value. So this is x, this is y, this is z, Now this is result. Okay. So now let's run this and see how many bytes. This is one of the famous interview question. So whenever you are writing code, in many of the product companies, they ask you how many bytes does it take. So please pay attention. The integer 10 takes 28 bytes, which is mind blowing because in C programming and C++ and Java, this would have just taken 4 bytes. So Python is extremely memory or resource intensive, extremely resource intensive. Then floating point takes 24 bytes. Then 1 second, I did a mistake here. I'm printing the same integer value as 1010. Otherwise it will confuse you. So let me go and change the code. Here I said integer 10 takes, right? So I'll say integer 5 takes. Then here this is floating point, sorry, float 1.2. Okay. Here it's not float, here it's integer. Here it is string, str Mahesh. Here it is boolean, true. Okay, let's run it again. See, to store 5 it took 1.2, it took 24 bytes, and Mahesh takes 47 bytes, and boolean takes 28 bytes. So what is a byte and what is a bit? I am sure you all remember this, but just I would like to refresh your memory. So this is 1 byte, which is equals to 8 bits. And in each bit, you can store either 1 or 0. Okay. And if this value, if this is unsigned means you can only store values greater than 0. So what is the range of value you can store? You can store from 0 to 2 to the power 8 minus 1. So how much is 2 to the power 8? It is 256 minus 1. So 255. It means in 1 byte data, if you have 1 byte memory, you can store the values from 0 to 255. When you use C programming, when you use embedded programming, if your range of values is only that much, then maximum you will use is only 1 byte. In fact, I have seen programmers where to store true and false you need only 1 bit, right? So even they optimize that. They pack multiple variables into single byte. Okay. So here you need only 1 byte. Okay. And the Boolean in C language takes only 1 byte. But the Boolean in Python is taking how much? It is taking 28 bytes. 28 bytes. So this is the reason Python is not a preferred language for the client applications. In the backend they will run because backend server will have a lot of memory. It will have a lot of power, it will have everything. But on your mobile phone, if we start using Python on your mobile phone, you imagine how much RAM, how much memory it will take. Just for single variable if it is taking this much. So why is it taking this much? Because it is not creating a primitive data type. It is creating an object. And what is an object? You will learn in object-oriented programming. So for now, you remember it creates an object. And when I teach you object-oriented, I'll teach you that as well. So there is lot of extra memory along with that storage that it is allocating. Okay. So then you may feel that why am I learning this kind of language, right? This is not so good. Why should I learn this kind of language? This is where I'll show the magic of Python, which is the Python can be extremely good with very large numbers. So it can be really good with extremely large numbers like this. Whereas programming languages C and C++, they will just crash if you do like this. Okay. And I will do one more thing, which is here, right? So I will just increase these values to extremely large values. And then we'll see what happens. Okay. So now again run this. Okay. Integer value I changed. How much was it earlier? Do you remember? It used to be how much? It used to be 28 bytes. Now it is how much? It is 52 bytes. So this value earlier, it used to be only 528. Now it is such a large value and it is 52 bytes. So what happened? What happened here? So this x value, it used to be just 5 and then I just added all these numbers and the memory increased. Similarly, let's see the other values also. Then floating point. Floating point also, this used to be 24 bytes and it is still 24. Then Mahesh, the text, this has increased to 1238 bytes. Earlier, how much it used to be? It used to be only 47 bytes. Now it is 1238. So what is happening? As your value is increasing, the number of bytes that are allocated is increasing. Okay. Is this possible in C program or Java or C++? The answer is no. In C, C++, Java, you cannot store such a large values because it allocates only and only 4 bytes. And what is the maximum value that you can store in 4 bytes? 2 to the power 32 minus 1. So 2 to the, how do you write power is that cap symbol? 1 second. To the power 32 minus 1. So the maximum value, that too a signed, okay, signed unsigned integer you can store is only this much. For that, in C, Python, C, Java and C++, they have another data type called long, which means it takes 8 bytes. Now with 8 bytes, the maximum, and by the way, how did I come with this 2 to the power 32? How that 32 numbers came? So 4 bytes, right? 4 bytes, each byte has 8 bits. So 8 into 4 is 32. In 32 bits, the unsigned value max you can store is 2 to the power 32 minus 1. Why minus 1? Because there is a 0 at the beginning. You are not starting from 1, right? You are starting from 0. That is why you do minus 1. But if it is signed, sign means both negative and positive numbers, then it cannot be 2 to the power 32. Then it will be 2 to the power 31. Power will also be 1 less because 1 byte will completely go away for storing whether it's a positive number or negative number. So in case of Python, this does not exist. You can, this number can be even extremely larger than what I have put here. Okay. It can be even large. Yep, sorry, not D. I have to put a numerical only. So it can be even this large and it would still work. It would still work. And it can handle these large numbers. That is the reason why for data analysis, for machine learning, all these fields of engineering, Python has become a famous or a more popular language. The Python's ability to handle these large numbers. It is just that it is very memory intensive. It takes a lot of memory. Okay. So let's get back to our notes and see, go in that same chronological order. Let's see what was the next type. The type part we covered. After the type, it is larger integers consume more memory and strings grow linearly with their length. Okay, that we saw the demonstration, how the memory increased as you increase the length. Now next part is called memory segments and variable storage. So this is the most important part, and please remember this question get asked again and again in the interview. And we have seen lot of students, especially the people who learn Python as their first language or last language, first and the only last language. They do not remember this or they do not understand it. And when you study this in the engineering, there will be very small section or a small page or a small portion on this, and many people may not study it or they may skip it. But for the interviews, this is one of the most important topic. In our first lesson, we explained that when you load a program in RAM, the program get loaded in RAM here, and when it gets loaded here, it's not just that it just copied your binary code into the RAM. It copies them in a certain way. Okay. And when it allocates the memory, there are boundaries to it. It is not that there is one flat allocation that happen. So these is called, and this is called segmentation. So that memory is allocated in segments. Okay. It is allocated in segments. So what are the segments? The first segment is called code segment, then data segment, then stack segment, and then heap. So let's understand what goes here. In the code segment, your binary code, your code goes actually. So your code, which is in, of course, everything is in binary in RAM. So don't worry that, okay, the other portions are not in binary. Everything in RAM will be in binary format. So this is where your code is stored. Okay. What is that data is stored? Data is stored your all, hard-coded values, static values, configurations. All this goes into the data segment. Now, when you start writing the code, you will see it. You will see what goes in data versus what get dynamically assigned. The stack is the most important part. And a lot of people, the mistakes they do in coding because they do not understand this portion specifically. Whenever you declare a function or declare a block of code and you are declaring the variable in that, it always get allocated in stack memory. Okay. So this you can call as temporary variables. Okay. Which are in that scope of the function. And then there is something called dynamic memory allocation. Dynamic memory allocation. So all the objects, they go here. Now what happens is when you learn engineering, right, you will learn operating system separately. You will learn programming language separately. Then you will learn the object-oriented programming separately, right? And you as a student have to connect the dots between all these disciplines or subjects. And this is where many of the people or students do not connect the dots, and in the interview they cannot answer certain questions. Because these things are interrelated. Now I am saying objects here. Now without knowing object-oriented programming, how will you know objects? Right? And this portion of this memory segments in our lessons, every time we go into the specific parts, we'll repeat it again and again, again and again. So why is that this kind of a system is done by the operating system? Why is that when you run a program, the memory in the RAM is allocated this way? Because the code segment is read only. Okay. Then data segment is read write. Stack is read write. Then heap is read write. Read write means you can change it. See, the data also will have some global variables and all that you can change. But related to access, the access, like say this is one process. Okay. Now there is another process. Let's say there is another process. Can this process read your code or read your data? The answer is no. The operating system prevents it from doing that. If operating system allow this to happen, then the hackers would steal all your money and wealth and everything from your phone. Imagine you have a GPay app and then there is another app which is running along with GPay app. And if that program can access this memory, right, it can easily ask your GPay app to transfer money to the hacker's account. So for security reason, operating system makes sure that each process has its block of memory and it is guarded. The second thing, when you start running the code, you do not know how much memory you need for heap, which is dynamically allocated. What is dynamic memory allocation? It means during the runtime, when that program is running, the memory is allocated. The best example is, let's say you opened a PowerPoint application on your laptop. When you open the PowerPoint application, the operating system or that application takes hardly 100 MB memory. But let's say you loaded one PowerPoint slides with maybe 50 slides in that file, then it allocates the required memory to it. Or you are opening an image, or you are opening a movie file to watch a movie, or you are launching your browser. So when that data comes in, at that time dynamically the memory get allocated. So it is allocated at the runtime. Okay, they say it is allocated at the runtime. So where is this memory get allocated for code and data? It get allocated at the load time. When that program is loading, it gets allocated. Some people mistakenly call it as compile time. That is not true. When you are compiling, you are only converting from high level to low level language. In compile time, there is no memory allocation. It happens at the when that program is getting loaded onto the RAM. And then comes to the excuse me. The next important part is the stack memory. Okay. So the way it works is, what is a stack, right? Stack is basically, you are putting things one above the other. So let's say I am creating a stack of books. So first thing is, this is the first function that I want to run. So you added that to the stack. Now internally from this, you are invoking another function. So you remember whatever the state you are in, and then you added the second function to the stack. Then from here you are invoking another function. So you added that to the stack. So why this is needed? Because what happens is, when you are running a software, the entire software is not written like a one big file. If you write software like one big file, one below the other, then what happens is you will repeat that code again and again, again and again. The best example is that print function that we were discussing a while ago. The print code is written by the person who developed Python, and it is there in the library. If you have to write that again and again whenever you want to print, then you will lose time. Second is, your program will become like very lengthy. So that is the reason the functions came. But now from one function you can call the other function. From there you can call another function. In that case, what happens is, the CPU has to remember where it left, from where it left. It is as good as, let's say, I was taking this class. Okay. All of a sudden, my wife says that some guest has come. Please come down. So what I will do, I will pause whatever I am doing. But I will remember where I left. I will say, okay, I was covering stack memory, and I was teaching this lesson. I will remember that, and I'll push it to stack. Then I went down and I was talking to the guest. Okay. By that time, I got a phone call. Let's say I was talking with that guest about our tour plan. Now that I push in my stack memory. Then I received a phone call. Now in that phone call, I am talking about our marketing strategy with our marketing team, right? Now as I was on that phone call, I received another phone call from my bank. Okay, so I pushed that marketing person. I told marketing person, please be on hold. I am getting a call from the bank. Now bank has called asking me that you have issued a check worth so much. So is this correct? I said yes. So they hang up the phone. Now where will I go? I'll go back to the call with marketing team. So I give my input to them, and after that I end the marketing call, so that get removed from the stack. Then my guest is there waiting for me. I'll talk to the guest and then I say goodbye to them. Then I remove that from stack. Then I'm back to my class where I was teaching stack memory. I complete teaching stack memory. I remove this from stack. So this is exactly how the stack memory get used by the program that is executing. It has to remember the context, and every function that you load in the stack, the state of that is temporary. When you are there, it knows everything about that state. When that work is done, it is clean. When that work is done, it is clean. It is exactly like that. So this stack memory here, it will grow as you call the function. So you call function f1, from there you call function f2, from there you call function f3, from there you call function f4. What if you kept on calling like this iteratively? You never stopped. And this is one of the interview question, a famous interview question, which is, if you kept on doing that, what will happen? Your stack memory keeps on growing and finally it will become full. And when it becomes full, what is it called? This is called stack overflow. Stack overflow. So what happened? Your stack became full, or you will say the stack has become full, and your program will crash or your program will stop. Okay, stack overflow or that stack memory is full. Then similarly, heap memory. Heap memory, you are dynamically asking. Let's say you are editing a very big PPT or a very big project, and you loaded that to RAM and you ran out of RAM. So then you get an error when this heap memory is full and there is no more memory left in the RAM. Then you get an error called out of memory exception. Out of memory. Out of memory means there is no more memory in your RAM and I cannot run your program. So it will throw the error, and the programs which don't handle it, they will all crash. Have you seen that, on your phone or on your laptop, if you keep it on for too many days and you have not closed many applications, suddenly it will become extremely slow and then you have to restart or it will get hanged. It get hanged because eventually your RAM will be full. And only when you restart, the power goes out of the RAM and then everything get cleared, right? So this is out of memory exception. That happens when your heap is full. When your stack is full, you get stack overflow. Okay. Now, code, nothing changes. It loads when you launch the program and then it doesn't touch. Data also, it sets it when your code start and then it doesn't change. It does not grow or shrink. Only stack and heap will grow and shrink, but stack cannot grow infinitely. There is a limit. After that limit, it will crash the program. Okay. Now, anything you declare in heap, it will be there as long as. So this is the main thing. Now, that life of that variable, life means the scope, right? Let's say this is the timeline. This is t. So you're starting at 0 and then say you're running at 10 minutes. Okay. Your global variables get started here only, where when your program starts, the global means they are declared at the beginning of the program. So they start at t0. Okay. Then your dynamically allocated variables, they go in heap memory. Okay. So they get started whenever you declare. Let's say you did a dynamic memory allocation, DMA, or you created an objects. So this get allocated where? It get allocated in heap. Okay. Till the point you free them, they will exist. If you free them here, they will die here. Okay. But if you don't free them at all, then they will die when that finally the process is ended. Either it is ended or it is being killed. That is when they will go. What about the local variables, the stack variables? The stack variables, let's say this is function 1 and function 1 is calling function 2 and then function 2 is calling function 3. The stack variables declared inside function 3, let's say x here. So the x will be only there as long as you are inside that function. That's it. Once you exit that function, this value is gone. Then once you exit this function, this value is gone. Once you exit this function, this value is gone. So as long as you are in that function, that value will be there. After you come out of that function, the value is gone. This debugging and repetition of this concept I will do again when I explain functions in depth. But as you are learning variable, please remember there is something called scope or life of variable that you need to understand very thoroughly. A lot of students make mistakes in the interviews in this. They'll declare variable, they don't know when it will there, when it will die, and they will unnecessarily access this variable. Variable lifetimes has one of the important areas where many people get confused, and this is something that even I have seen people get confused while they are explaining it in the interviews, or I have seen some blogs and YouTubers where even they have made it more confusing. So there are basically 3 words and very popularly used 2 words, which is called compile time memory allocation and runtime memory allocation. Okay. Now to understand this, let's go ahead and see what is compilation and what is compile time and what is runtime. So if you understand that, then your all doubts will be clear. Let's take a high level language like C, high level language like say you have a program a.c. Okay. And in this there is a global variable. Let's say global variable by name, let's say age limit. Okay. That age limit is a global variable which is set to 18. And within this you have other variables which are local. So how the local variables are done? Let's say there is a function and inside this function there is a variable called age into 10. Okay. Now when you compile this high level language a.c and you give this file which is stored where this file is stored in hard disk drive, HDD or SSD, and you give it to a compiler. So what does compiler do? It will go through this file, understand the code and see what standard library functions are you are using. So it takes all of that code and the output from here is a binary file. And generally if it is a Windows machine, it is an exe file, executable. And in this executable, it has organized this code into 2 parts. One is called code part, another is called data part. Now in this data part, it will make sure this variable details is added. So it says that there is a global variable which is called age limit and it is of type what? It is of type integer. So generally on say 32-bit machines, the integer data type takes 4 bytes of memory. So here in data segment, it will say that age limit will take 4 bytes and the value that is set is 18. Okay. And the other variable here, which is int age 10, this is inside a function, which means this is local variable to that function. And the variables which are inside a function, they are declared inside a function which are local to that function. The memory for this get allocated in stack memory or in stack segment. So in this binary file, there is no information about it, or in data segment, there is no information about it. And finally, you take this executable and you double click on it. You click on it or you invoke that executable. What happens? Then that program get loaded in the RAM. It get loaded in the RAM like this. So you have here code segment, you have data segment, you have stack segment, then you have heap segment. So your a.exe get loaded in the RAM. Okay. When it loads the program, at that time, the memory for this data and code segment get allocated. So it get allocated in the RAM when the program is loading at that time itself. You can call it as load time if you want. So this it can be called as load time. Now when is the memory for this get allocated? The local variable stack, which is declared inside the function, it get allocated when that function get invoked, when that code get run. At that time, that local variable get allocated in the stack memory. And if you are using object oriented programming or dynamic memory allocation, at that whenever you do the memory allocation by creating an object or dynamically allocating, that one get allocated in the heap segment, DMA, or you create objects. So it get allocated in the heap segment. And now when it will get freed, in case of stack memory, the moment you are out of that function, it get destroyed, it get freed. And when does the data segment get freed? It get freed only when that program is killed, when that program is terminated, or when that program itself complete the work and exit from the RAM, or it finish the execution. So when it finish the execution, operating system will remove that program from the RAM. That is for the variables which are in data segment, the global variables, right? For stack, anyway, once you out of the function, it get freed. For heap memory, it can be freed only in two ways. Not two ways, three ways, sorry. Three ways. The first is where the program is terminated. Once program is terminated, all memory get freed. Second is where the programmer has asked it to free. They explicitly say free this memory. The third is where the garbage collector, which is a specialized process, I'll explain that in a while, that comes up and cleans this memory. So having a detailed understanding of this compile time, what does it mean by compile time allocation? What does it mean by runtime allocation? What does it mean when it get allocated during the load time or when that program is loaded to the RAM? So understanding this distinction and be able to explain is super important for your interviews. So this determines life scope and how it get allocated in the RAM and different segments of the process in the RAM. Super important. You go and read about this more in the online platforms or use the LLMs, but please thoroughly understand this and try to make your own notes and explain it to yourself. Okay, now there is one more concept that is super important, and again I will not go into the depths of it. This is just an introduction. You will learn it again in object oriented programming. Okay, like I said, this heap memory, right, you allocate here and you free it here and it will get destroyed. Okay, now in olden days, in say C++ and languages that came at that time, the developer have to allocate it and free it. But what used to happen is many of the developers used to forget freeing the memory. Since they used to forget freeing the memory, then there used to be a leak of the memory, and that was called memory leak. This is again an interview question. What is memory leak? The memory leak means a dynamically allocated memory is not being freed by the program, and that space is unnecessarily held in the RAM, and that leads to memory leak. And many times in the backend system, we have seen that it takes less memory to run, but somebody did not free the memory properly, and because of that, it now takes more memory to run because it will keep creating these black holes, the unused holes in the RAM. So that is what is memory leak. So this I will cover when I cover object oriented programming at a greater depth. But for time being, you remember in the programming languages like Python and Java, there is something called garbage collector. Garbage collector. So the name is very self-explanatory. If you have declared a variable, you have allocated the memory, you have finished your work, but you have forgotten to clean it, The garbage collector comes once in a while and look at all such variables and remove them from the RAM. That is the job of this garbage collector. So it can run every 5 seconds, it can run every 10 seconds, but its job is to deallocate the unused memory, unused variables or unused objects. That is the role of garbage collector. So Python and Java has this. Okay. Now coming to the mathematical operations, since you all are students of engineering, I know you know algebra really well. There is only one operator that we generally don't use in math, which is modulus operator. Rest all addition, subtraction, multiplication, division, floor division, exponential, all of this. Already you studied in your academics, right? So these are two operators that you may want to remember. One is this modulus operator, which gives you the reminder. That gives you reminder. What does that mean? Let's say you are doing 10 modulo 2. So you are doing 10 modulo 2. What would be the answer? The reminder would be 0. But if you are doing say 10 modulo 3, the reminder would be 1. This is in lot of interview questions. The modulo operator is being used and it's a very interesting operator. So just remember that such operator exists and you will learn with examples when we use it. And then of course exponential, a to the power b. Now type mixing causes error. It means if you try to mix the types, you will get an error, and that demonstration is here. Okay, so I will show this with example how these types are very strictly checked. So let's write this code and then see the demonstration. I'll set one breakpoint here. Let's remove all of this. Okay, so you saw the output here. It is saying 7.0 and high and 5. Okay, but however, if I uncomment this line and run it, what happens? I'll set one breakpoint here. Remove this breakpoint, run till the end. So one variable here is of type string and another variable is of type integer. So when I run it, you get an exception, can only concatenate str, not the int. So this is called type error. Type error because these two data types are different. Whereas these two it worked because their type was same. Here also it was a string, here also it was a string, it worked. Here it was a numerical, here it was a float, but it could convert this to float and do it. Int plus float, the answer is float. High plus 5, high 5, right? So it was able to do this. Now there is an important part that we missed as we scroll through our notes, which is mutability and immutability. So in the notes there was a section for being it whether it's mutable or not. Looks like I skipped it, and that's another important thing that we need to cover. This portion I think I skipped while explaining, so I'm going to cover this, and this is one of the most important part again when it comes to the interviews. So there is a concept of mutable and immutable. Okay, and this may sound very weird, and you will feel that, oh my god, Python is so not efficient at all. Okay, let's say you declared a variable called number and you stored value 10. Okay, in any other languages like say C, C++, Java, what happens? If you change this value from 10 to 20, it just changes the value in that place only. It just updates the value in the RAM. But only in Python, if you change the value, this memory get freed and some new memory get allocated where it will set the value to 20. In Python, you cannot change the value. If the value get changed, this get deallocated and a new allocation happens and the value gets stored. Since you cannot change the value, the technical term is called immutable. Immutable means you cannot change the value. So why it happens and what are the reasons is what you need to understand. But before we go there, let's see what are the data types where it is immutable, it cannot be changed, and where it can be changed. And that is very nicely put in this table. So integer is immutable, float is immutable, string is immutable. You cannot change it. So every time you touch it, you make some modification, a new memory get allocated and old one get destroyed. List, you can change. Tuple, again, is immutable. Now, what is a list? What is a tuple? These are data structures that I will teach in data structure lessons. So don't get confused. Let's skip data structures and directly get into Boolean. So its Boolean is also immutable. It means all your basic data types like int, float, string, Boolean, all of them are immutable in Python. You cannot change those values. Every time you change those values, a new memory get allocated and value get assigned. A new memory get allocated and value get assigned. Why is this? So this is because it really helps in a multi-process or multi-threaded coding. Now there is a concept of process and threads. There is a subject called operating system that you all learn in engineering. So how the code runs. For you to understand right now, you just imagine that your data is one, but your code is broken into small threads. Okay, there are like multiple people who are running your code, and when they do that, they may be reading and writing the values to it. Okay, they may be trying to read and write values here. Now if 2-3 people, let's say you have a TV in your house, and I'm sure many of you have siblings, and there is only single remote for that TV. So what happens? You all fight to get that remote, and somebody may put one channel, the other sibling will change the channel, somebody will remove the power, and the fight erupts, right? So here also the same thing happen. If your code is running as small threads parallelly, and there is a single variable, and they all are trying to change the value, the fight starts between them. And to prevent that, this concept of immutability is introduced, so that there is no way to update. If you want to update the new place, new variable will be assigned. So it makes your code thread safe. You remember the word thread safe. When we have a lesson on operating system where I explain processes and threads, I'll explain this concept again. So when you learn the concept, it just feels illogical. Why did the creator of Python introduce this concept? But when you get into that multiple processing and threads, multi-threaded programming, then you will respect this design. Okay, so this covers, I think, all the topics of what we wanted to learn in variables. See, generally I have seen when you start learning variables, they know data type, they know what is the range, and you declare them and use them. But when you want to excel in the industry where LLMs and ChatGPT and Copilot and GitHub Copilot, they are helping you write code and write inside your IDE. Understanding these variables at this depth is what sets you apart from other engineers in the industry. So I have shown you the way, I have shown you the depth and breadth of it. You go to internet and read this further and understand this further. And as you study other subjects like operating system, you relate that back to this understanding. And please read these notes and also try those coding samples I explained in the code. To summarize our discussion today, we learned about variables, why we have variables, what are the different data types, what is the life and scope of those variables, how much bytes get allocated, segments in the process, the variables in which segment they get stored, when they get created, stack overflow, memory leak, how heap memory and stack memory grows, Then we learned immutability and mutability and immutability of variables, which variables are immutable and mutable. And we also learned why that was designed, why that is designed, because of thread safety, multi-threaded programming, right? So holistically, when you learn like this, you really become a good engineer and you can design some of the complex and scalable systems. I hope you like this lesson. If you're watching this video on YouTube, please share your feedback on in the comments. And if you're using our mobile apps, please go and drop your feedback on our Play Store reviews or App Store reviews. And if you're watching it on our website, please share your feedback in comments. Thank you. Namaskara.